I realized yesterday when I was done teaching that I forgot to teach you one section in there, and I think most of you figured it out. But it said if we have 3x plus 10i, and that's equal to 12 minus 5yi, what do x and y equal? So we have a complex number on the left with an x in it, and we have a complex number on the right with a y in it, and so this is equal to this. So what number makes those true? 4. So x would be 4. And likewise, this is equal to this. So negative 5 times y times I is equal to 10i. The only number that works is y equals negative 2. Does that make sense? And some of them were a little bit harder. So we would have like, 4 minus 3yi is equal to 8x plus 2i. So I know that this piece and this piece are equal. So what would x be? 1/2. 8 times 1/2 is 4. So x would be equal to 1/2. And then I know that this piece is equal to this piece. That's a little bit harder to do. So what if we just wrote it out? Negative 3yi is equal to 2i. Well, I can divide by I and get rid of it. And I'm just down to negative 3y is equal to 2. How do I get y by itself? Divide by negative 3. I get y equals negative 2 over 3. Does that make sense? Okay. And then just a review from yesterday. If I had the square root of negative 48, I could break that down into 8 and 6, 2, 2 and 2, 2 and 3. What can I bring out? Set of 2's and another set of 2's, and the I. So on the outside, I would get 4i, and on the inside, I'm left with 3. Is everyone all right with that? And if I had 2 minus 3i minus 6 minus 4i, how would I combine those two complex numbers? I need to bring the negative inside here. So it would end up being negative 6 and positive 4i. And then 2 minus 6 would be negative 4. And then negative 3 plus 4 would be plus 1i. Does that make sense? Okay, now we're going to be multiplying i's together, which is a little bit weird because some strange things happen. But if I had the square root of 3 times the square root of 2, how do I multiply those? What would you do? It's just the square root of 6. The square root of 6. Okay? If I had the square root of, let's say, 6 times the square root of 12, I'm going to get the square root of 72. But 72 probably simplifies. So I break it down into 8 and 9, 2, 2, and 2, 3 and 3, set of 2's, and a set of 3's. So I get 6 square root of 2. Is everybody okay with that? All right. What if I had the square root of 5 times the square root of 5? That's going to be the square root of 25, which is actually just 5. Does that always work that way? If I had the square root of 3 times the square root of 3, what's the answer? Square root of 9, which is 3. Which makes sense because this is saying, this is saying what number times itself is 3? Well, the square root of, the square root of 9 is 3. What number times itself is 9? That's what I meant to say. If I had the square root of 7 times the square root of 7, the answer is just 7. Okay. Well, what if I had I times I? What's the answer going to be? I squared. But what is I? It's the square root of -1. So I'm asking, what is the square root of -1 times the square root of -1? Well, according to the pattern, it has to be -1. The square root of -1 times the square root of -1 just has to be the stuff on the inside, because the square root of x times the square root of x is x. Right? And the way you can see that is if we write it this way. The square root of -1 raised to the second power. And the second power cancels the square root. And we're left with -1. Okay? Well, what would... Well, so this is -1. What would I to the third equal? Well, that would be I times I times I. And I know what this is. I times I is -1. So it would be -1 times I, which is just -I. So I to the third is -I. What about I to the fourth? Well, that would be I times I times I times I. And these two make -1. And these two make -1. And what is -1 times -1? 1. Whoa. So I squared is -1, I to the third is -I, and I to the fourth is 1. What about I to the fifth? Well, that would be I. These make -1, and these make -1. What is -1 times -1? 1 times I is I. Okay, if I add another one, I to the sixth, these two make -1, these two make -1, and these two make -1. And what is -1 times -1 times -1? -1. I to the seventh, I just add another I. -1 times -1 times -1 times I is -I. Do you see a pattern? What's the next one going to be? So I to the eighth is 1. And I to the ninth is going to be... Oh, sorry, this should be -I. No? No, that's right. So I to the ninth is going to be... So there's 8, and here's 9. negative 1, negative 1, negative 1, negative 1 turns into 1, negative, and so positive I. Right? And that pattern continues forever. I, negative 1, negative I, 1. I, negative I, negative, negative I, negative 1, negative I, 1, and so on. Okay, now we really don't need all of those. All we really need is this one. If we know that rule, then we can figure out all of the others. Okay? So what would 3 times 4i equal? Well, I just multiplied in, and I get 12i. Okay? What is 6i times 3i? That would be 18 I to the second. But what is I to the second? Negative 1. I squared is negative 1, so this actually turns into 18 times negative 1, which is negative 18. Got it? Okay. And then you can run into stuff like this. 3 plus 4i with a 2i on the outside. I multiply this in. That would be 6i. And then I multiply that in. 8i squared. But I squared is negative 1. So it's actually 6i minus 8. And we never write it this way. We always put the I last. So we would need to switch them and get negative 8 plus 6i. Does that make sense? Okay. What if I had this? 3 minus 4i times 6 minus 2i. How would you multiply those together? Any idea? You would use the box, exactly. You would put 3 minus 4i on one side and 6 minus 2i on the other. 6 times 3 is 18, and 6 times negative 4i is negative 24i. And negative 2i times 3 is negative 6i, and then 8i squared. And we know that 8i squared is actually just negative 8. So I'm going to change this into negative 8. And 18 minus 8 is 10. And negative 6i minus 24i is negative 30i. And that is our complex number. Okay, let me look at your assignment for a second. Are we on 4.6? Okay, so I need you to go all the way to 48, but there's one more we need to do. What if I had 2 plus 3i to the second? How would you do that? Can you say 4 plus 9i squared and then simplify that? How do you square a binomial? You have to write it twice and then use the box. You cannot say 2 squared and 3i squared. That doesn't work. You have to use the box. So we would put 2 plus 3i on one side and 2 plus 3i on the other. 4 plus 6i, 6i, and then 9i squared. But I know that I squared is just negative 1, which is going to change the sign here. I end up with 4 minus 9 is negative 5, and 6i and 6i make 12i. And that would be the complex number. All right. So on your assignment today, stop when you figure out 48. If you look at number 45, it says justify each step. So you just need to write, there are 4 steps. You just need to write what happened at each step. How did we go from the top line to the second line? What mathematics was done? Okay. And then all the way to the bottom. Number 47, you have 4 numbers, 7, 4, 3, and 6. Can you arrange those 4 numbers into those parentheses so that the problem is equal to 2 minus 4i? Okay? You have to look at those 4 numbers and decide where they go to equal 2 minus 5i, and the same thing with number 48. And then we will finish this assignment next time.